to WizBiz.com, and today we're gonna take a look at these little tiny boards, and this is what we call a TP223 touch sensor. Comes in a snap off and break off fashion like this. Very tiny sensors, touch sensors that we can use, well, to substitute a normal switch in our electronic experiments. But first, let me show you the old-fashioned way of switching this vintage Fisher Technique Silberling. Just by a switch, well, nothing happens, of course. I have a clock pulse here, and when I make this clock pulse high and low again, in this fashion, you see it will switch. And this is normally done at this moment just by putting the wire to the plus and then to the minus, which means in the negative logic of this Silberlings means a high signal or an active signal. So we can switch like this. But when we are gonna do that with a microcontroller or an Arduino, for instance, we have to take care, because at the moment of switching, and even if we do it with a regular genuine switch like this, a micro switch, you see this old-fashioned vintage flip-flop module built up out of discrete components is very forgiving. But when we gonna do this with digital logic and CMOS chips and microcontrollers, we have to take care, because at the moment of switching, I can see if, let me see if I can make it fail. No. At the moment of switching, there is a lot of noise generated here, and that can be misinterpreted as a switching moment. So in software and in our Arduino sketches, we have to take care and build in a waiting loop to let the new potentials levels settle, and then we can be really sure if it's a high or a low signal. So switching with a mechanical component as a switch in your electronic circuits and in your flip-flops, and use that as a clock cycle or a clock pulse, is not a very good idea. Fortunately, there are a lot of sensors like these, the passive infrared obstacle sensor, and the aforementioned touch sensors that have a built-in op-amp that makes a very steep edge to your pulse and doesn't have the denoised or debounced, as they call it. So we can use this right away. If we have a 5-volt power supply for these things, we can use them. On the TP223 that I have here, specifically, some things can be changed in the behavior of this little thing by soldering these A or A and B solder jumpers over there on the tiny PCB. If we do that, we get some differences in behavior. If we, for instance, if we solder the A jumper over here, the whole logic changes from positive logic to negative logic. So the normal output will be high after you switch it on, so it will be 5 volts, and when you activate it, it sinks to 0. Otherwise, it's the other way around. If you solder it close, then it will have negative logic, so everything signal-wise will be the other way around. Okay, let me take a look and let me show you what I made. I made these small 3D printed stones. I got 2 kinds of these because there's a small LED on the board as well. These are printed with transparent filaments. The light of the LED will shine through, and I'll show you in a moment. So this is one in which the PCB is still exposed, and this is one in which the tiny PCB is completely enclosed with a tiny stone that can be used with Fisher Technique like this, it has a small feather-like rim to it, so it will connect to the Fisher Technique construction system, and we can use it in the Fisher Technique construction system. Let me show you what I made. This little tiny power module is also on my timeline here in YouTube, so take a look at how we constructed that. It just gives the sensor 5 volts through a little servo cable like this, and this plugs in here. So if we plug this in, we have the signal. Let me plug it in. We have the signal over here at this bus over here. So we can use the clock pulse bus from the vintage Fisher Technique Silberling flip-flop. We can use it to switch that. So here we go. As you can see, it works like a charm. The moment you make contact or you're in the vicinity of this sensor, you don't even have to touch it. Well, it just lights up the LED, and the light of the LED is visible through the building stone, because I've elevated the PCB a little bit in the stone, and it works just the way as the normal mechanical switch did a moment ago. I took this even a step further with these stones, these very tiny, slim 5mm thick stones, and I can demonstrate you as well. Let me switch this on. Here we do nothing really with the signal in itself, but it's just for demonstrating purposes, so I can show you what's going on here. As you can see, they also work very nice side by side. There is no you can really address one of these sensors. They're not too sensitive, they're just okay, and you can make a complete bar out of it. For instance, you can make this way longer, because these things are really cheap. So if you print yourself 20 of these stones, you can make a control strip out of this for all kind of funny purposes. Alrighty, so 3D printing, by the way, of these types of building blocks is of course absolutely not necessary. A drop of hot glue is sufficient if you like to go hands-on immediately. The big advantage is that there is no switching noise, such as with mechanical switches and push buttons. So this might also be useful for your electronics or microcontroller project. If so, or if you find these videos useful, don't forget to give me a thumbs up or subscribe. Okay, I'll go on tinkering a little bit more here. Hope to see you with my next video. Until then, happy hacking!